You might think of physics as a bunch of complex equations and theories that have nothing to do with our bodies. But here's a fun twist. Physics plays a crucial role in how your blood flows. Yep, the very reason your heart keeps pumping is rooted in the principles of fluid mechanics. In this video, we will dive into the world of viscosity and discover how it impacts blood flow through our veins. Plus, you will learn how even tiny changes can have big effects on your health. So let's get started. It's viscosity anyway. Think of it as a fluid's internal resistance to flow. It's all about how thick or sticky a liquid is. Take water for instance. It's got low viscosity, so it glides along smoothly. Now, honey? That's a different story. It's thick and doesn't flow easily. How about blood? It's right in the middle. Not as thin as water, but definitely not as thick as honey. In physics terms, when a fluid has higher viscosity, it means there's more internal friction, making it flow slower under the same pressure. Now let's talk about Poisson's law. Sounds fancy, right? This equation explains how blood and other fluids move through tubes, like our arteries and veins. The flow rate, or how quickly the blood moves, depends on the pressure difference between 2 points, the viscosity of the blood, the length of the blood vessel, and most importantly, the radius of the tube. Here's the kicker. Because the radius is raised to the power of 4 in this equation, even a tiny narrowing can seriously slow down blood flow. That's why clogged arteries can lead to high blood pressure. It's physics at work right inside your body. Every time your heart beats, it creates a pressure difference that pushes blood through your vessels. If your blood thickens, say from dehydration, that viscosity goes up, making it harder for your heart to keep everything flowing smoothly. And when arteries narrow, that radius shrinks. Remember, since it's raised to the fourth power in Poisson's equation, even a small change can lead to big issues, like hypertension or putting extra strain on your heart. You know, it's pretty fascinating how physics is right there in the medical field, helping us every single day. Take IV drips for instance. They rely on the height of the fluid bag to create a pressure difference, which in turn controls how fast the fluid flows into your veins. It's like a little science magic trick happening every time you get one. Then, there are artificial heart and blood pumps. They are designed using equations that account for viscosity and flow, essentially mimicking how our natural circulation works. It's like having a personal physics lab inside your chest. And let's not forget about blood viscosity. Measuring it can help doctors spot issues like anemia or dehydration. So you see, fluid mechanics is literally saving lives out there. Alright, let's break it down with a little visual. Picture this. Water flows quickly, while honey, well, it's a slow mover. That's the same concept happening inside your body. When your blood gets thicker, it slows down, and your heart has to pump harder to keep things moving. Kind of like trying to push a thick smoothie through a straw. It takes some serious effort. So, what's the takeaway here? Blood flow isn't just about biology. It's all about fluid mechanics at play inside us. Concepts like Poisson's law, viscosity, and pressure differences are all working together to keep our blood moving like a well-oiled machine. Physics isn't just for the stars or falling apples. It's the very motion of life itself. And that's the cool science behind blood flow and viscosity.